Hi, in this video, I'll show you how to solve this differential equation. It's a first order differential equation. So for all of these, before you jump in and solve, you should always spend a few seconds at least thinking if it's one of the easy forms, meaning these three forms. Number one, figure out, is it separable? Number two, is it linear? A linear equation is easy because you can solve using integrating factors. And number three, is it exact? Now, an exact equation is slightly complicated, but it has a fixed method of solving. So you just go through the steps and the exact equation is solved. That's why I classify it under easy equations. All right. Spend at least a few seconds deciding if it's one of these three. Is it separable? I have a video on separable equations and how to recognize them. Okay, so check out the link above. The idea is, can we multiply and divide things both sides so that all the y's are on one side with the dy and all the x's are on the other side with the dx? And in this case, no. You look at it and you spend a couple seconds doing algebra in your head, and you realize, no, there's no way I can get that done. So it's not separable. Is it linear? No, it's not linear. It has y in the square root. Is it exact? This one, at least at the beginning, it may take you some time to figure out. Think of it as dy dx is equal to the square root, which you can then revise as dy is equal to square root times dx, and then you can move the dx to the other side like this. And now you look at whether or not the partial differentials of these two coefficients are equal. And no, the partial derivative of this one with respect to x or with respect to whatever is a 0. And this is non-zero. So yeah, not exact. So none of these easy forms applies. We ignore them all. We move on with solving it a different way. All right, this equation, because of this crazy square root here, is just asking for a substitution that goes v is equal to all of that. There's an alternative solution where you can substitute v using just the inside. And if you try doing that, you'll see that eventually it'll be exactly like substituting the entire thing. So yeah, either way it would work. I'm going to choose to do v is equal to the entire square root. V as a function of x is equal to square root of y minus x plus 1. That means v prime is equal to 1 over 2 times the square root times the derivative of the inside as chain rule, right? So times y prime minus 1. Well, this is actually v. So it's equal to y prime minus 1 over 2v. So I isolate y prime now because I want to get to this. So I'm going to isolate y prime 2v v prime is equal to y prime minus 1. And then I add 1 both sides. Then this is equal to y prime. Great. I substitute in. I have 2v prime plus 1. I substitute in for y prime. And then on the right-hand side, I have that square root. But I already substituted that square root for v. So the whole thing is just equal to v. This is a separable equation. 2v v prime is equal to v minus 1. If I divide v minus 1 both sides, is equal to 1. So now it's separable. I'm going to rewrite the v prime as dv dx so that I can multiply dx both sides. And here's my separable equation. So I can just integrate both sides. This is just going to be x plus c. Part is easy. I'm going to leave that. I'm going to look at this. This is a rational function. So one way to do it is to actually do a long division, 2v divided by v minus 1 and end up with an answer with a remainder. Or you can manipulate some algebra. I noticed that 2v is almost twice of v minus 1. The actual 2 times v minus 1 is going to be 2v minus 2. So I'm missing a minus 2. I'll do like completing the square, except that I'm not completing a square, I'm completing a multiple. So I want 2v minus 2, so I'll put it in. I'll put in a minus 2. And then just like completing the square, you subtract or you add something extra, you have to undo it. Minus 2 plus 2. This is 2v minus 2 over v minus 1 plus 2 over v minus 1 dv. That's all of this is just 2. The integral of this first integral here is 2v. And this integral here is an ln. And this whole thing is equal to x plus c. I mean, this equal sign here is correct, but just to separate out this equation, I'm going to make that, I'm going to erase it. I'm actually done. I'll just substitute back in. There we go. That's the answer. All right, the last thing I want to say is that this square root here, by definition of square root, is always greater than or equal to 0. Okay, it's never negative. But the square root minus 1 could be negative. And therefore, you need the absolute value. This is one of those situations where you cannot just omit the absolute value. Right, that's it. That's the solution. Any question? Ask in the comment section below. Like, share, and subscribe for more contents. And thanks for watching. Bye.